What's going on, guys? This is Romel with Jack's Tutor. Let me try to get live on here. Hey, what's up, guys? It's Romel with the Jack's Tutor. We are live. Let me see if I can get some folks on TikTok to show up, and then I'll set up Instagram in a little bit, and then we're gonna get into what we're gonna talk about for today. I think today I'm gonna connect my microphone so I can get better sounds. Right. Let's see who's up. Who is live with me? I'm gonna double check if this is live on Facebook first, and then we'll go live on Instagram. Let's have Blue Jar Zero. What's going on? Let me see. All right, cool. I think this is live on Facebook as well. Yeah, I think this is live on Facebook. Sugar Cookie, what's up on Facebook? Let me try to see if I can go live on Instagram. And hey, you guys on TikTok, if this cuts out, I know last time, I don't know what happened with TikTok. They say I violated their community guidelines. Have no idea what I did, but if this cuts off, just go on YouTube. I mean, actually, you should go on YouTube too. That's how you're going to see the screen. Let me see if I can go live on Instagram, and that would be it. So we're live on Instagram, Facebook, and YouTube and TikTok. What's going on? Hey guys, if you have any questions, ask them now, and before we get started, so that way we can. Sammy, what's up? That way we can all be on the same page. It's always hard to get this thing to hook on Instagram. Give me 1 second. I'm gonna try to make this work on IG. I'm gonna connect my mic as well. You can tell that I was prepared for this. Hey, you guys should all go on, if you on TikTok or Instagram, you should all go on YouTube to view the content, because otherwise you won't be able to. This won't make sense to you at all. Let's see. Oh. It's always hard setting this up on Instagram. Okay, what's up, Sammy? Hey, 7-11. What's going on? See if I can get this to straighten up. And yeah, if you are on Instagram or TikTok, just trying to go on YouTube, because that's how you'll be able to see the screen and everything that I'll be doing. Let me know what questions you guys have. Let's see. Hey, what's going on? Today is a wonderful day. 12390. What's up? We're gonna get to what we're doing today. I'm sure you guys will be excited about it. Mostly today we're going to talk about. I'll talk a little bit about system of equations, solving equations and systems of equations. SAT prep. Okay, some of the stuff that we're going to do here applicable to the SAT. You know what? Since you make this, let's try to see if we can do some stuff here. a lot of stuff that we're gonna do here are applicable to the SAT. But I'll try to see if I can throw in some questions for you about SAT. What else that you guys want to see today? SAT. Hey, what's going on? LYLIU. Please help. It's Don't Soap, you are hilarious. What else we got besides SAT prep that you guys want to see? I'm gonna see if I can get some questions on SAT for y'all. Anything else that you want to see besides SAT? I'm gonna solve some quick questions on SAT for you. What's going on Instagram? Yiki's is Kayla. What's up? Dividing polynomials. Okay. All right, so we could probably do some of that today. Dividing polynomials. Okay, what else? What else do you want to see? What's up? Yes, I do pre-calc. 6. What else you guys want to see besides dividing polynomials? Dividing polynomials, SAT questions. Okay. Someone said something about parallel and perpendicular line. And I think there was a slope-intercept form. Okay. Polynomial expressions. A lot of requests about polynomials. Okay. I think I got those last time too. Let's see if we can divide 6x squared. And I'll show you an example for 7x plus 20. Let's see if we can divide that by 3x minus 4. 2x plus 5. All right. Let's see if we can divide this 2x plus 5. Okay. Let's see if we can do that. Are you guys able to see my screen? Yes, no, maybe. You got to go on YouTube to see the screen if you want to see it. Oh, Facebook too, actually. You guys able to see the screen? parallel and perpendicular line. All right, cool. So let me share the screen, and I'm gonna see if I can get into an SAT questions for you guys who are asking for it. I'll put this somewhere else. So if you go on YouTube, you should be able to see my screen. We're gonna do some long division here for polynomials, and then hold up. Maybe I need to share that screen first before you can see it. Okay. All right. I think the audio. Let's see. All right, let's get this started. Let's see. Screen share. Wait a minute. Cool. Yeah, you should be able to see my screen now on YouTube. Let me double check actually. You should be able to see the screen. So the link is youtube.com/thejackstutor. We're gonna do polynomial. Yes, you should be able to see the screen now. It says it's live. I can see you guys watching. Let me see. Yes. Okay. So yeah, now you're able to see my screen on YouTube. Okay. So let's do this long division right here. So normally what we're gonna get into now is dividing polynomials. I saw a lot of requests for this. So basically, so what this is you have polynomials and you want to divide it by something else. You know, it could be. So it's just the same thing as if you had 8 divided by 2. It's just the same thing as if you had that. But in polynomials, what not only you're gonna consider the numbers, but you also gonna consider the variable. So we're gonna work as it step by step, just like we would do if we were working with numbers. So the first thing we want to do is saying that, okay, we have, let me go in a different color maybe. So we have 6x squared plus 7x minus 20. We're going to divide it by 2x plus 5. So we want to know, we want to know how many, that one thing that we need to start with. Whatever you're going to multiply this by, so whatever is going to come here, whatever you're going to multiply this by, it needs to be the same sign as this. So when you multiply, whatever you multiply this by, whatever comes here. So let's say we don't know what's going to come here. Whatever is going to come here, when you multiply it by here, by this first term, the highest term in this thing, it's going to cancel. It's going to cancel out this. It's going to cancel this out. So that's probably the easiest way to explain it. So you know exactly the numbers are not coming from out of nowhere. They're coming from knowing the fact that when I multiply whatever the term here, I multiplied by the highest term in this polynomial or monomial, it's going to cancel this highest term right here. And then we're going to cancel that the squared, the term in x squared. We're going to cancel the term in x. We're going to cancel after that, we're going to cancel the number. So if we had x to the third, we're going to try to cancel that first. We're going to cancel, so when you cancel in x to the third, you don't worry about x squared or x or the number that you have. So we're going to cancel x to the third, we're going to cancel x squared, and then we're going to cancel x. If we had an x to the fourth, we're going to focus on canceling that. What I mean by that is we're going to multiply this guy, the 2x, by a term here. When we multiply the 2x by that term, we're going to find something that cancels this, the highest term in this polynomial out. So the way we work on this, so the layout is, the way we're going to work on it is making sure that you cancel the highest term each time. So you cancel an x to the third, x squared, and then you cancel an x. When you cancel an x to the third, that's what you're focusing on canceling. Everything else doesn't matter because they're going to get canceled later. When you cancel in x squared, you're focusing on canceling x squared. Everything else doesn't matter. So let's do this. It's not, it's similar to numbers, but in this case, not only you you have numbers, but you also have letters. You got to make sure that you cancel them one at a time. You can't just go back to trying to cancel the 20 first and then work your way to the x and then x squared. It doesn't work that way. You got to cancel the x squared, find a term that cancels that out when you multiply it by here, by whatever here. Find a term that cancels that out, and then find a term that cancels x out. And I'll show you exactly what I mean in this case. So let's go start with 2x plus 5. That's what I had here. So here I had 2x plus 5. Let me put that in black again. Actually, I'll put that in a different color so you know there's a difference between those. 2x plus 5. Now, so we have 6x squared, and I'll change the color again to red. 6x squared plus 7x minus 20 divided by 2x plus 5. So what can I multiply 2x by to get 6x squared? Now, remember, what I'm focusing on is canceling the highest term. In the polynomial here that I have, the highest term is, 6x squared. So the x squared is the highest power. The degree of the polynomial is 2. So that whole term, 6x squared, I need to cancel that. Now, what do I need to multiply? What do I need to multiply 2x by to cancel that, to make sure that's gone? What do I need to multiply 2x by? Let me see if I can find some answers. On YouTube, I'm not sure if the chat is on. Show. Let me see if I can find some answers on YouTube. I think my chat may be lagging probably. So what do I need to multiply the 6x by to cancel that, to cancel out the 6? What do I need to multiply 2x by to cancel out the 6x squared? And then I'll do the first one for you. And then if you're not able to, because I don't think I'm seeing the comments now from YouTube. If you don't understand what I'm saying, is I'll do the first one for you so you can understand later on. So what I need to multiply the 2x by to get 6x squared is 3x, another 3x. 3x times 2x is 6x squared. So 3x times the 2x is 6x squared. That's what I mean by focusing on canceling the highest degree, highest term in a polynomial. So the 3x, you're going to multiply that by another 2x to get 6x squared. Now, because 3x times 2x is 6x squared, and then when I come to this side, what I put is minus 6x squared. So 2x times 3x is 6x squared. 6x squared, I subtract the 6x squared from here. It's minus 6x squared. So then we're going to move on to the next. So that 3x, I still need to multiply it by this guy. Because I multiplied it by the 2x, I still need to multiply it by the 5. What's 3x multiplied by 5? What is that? Whatever you have, you're gonna flip the sign. So 3x multiplied by 5 is 15x. Whatever you have, you're gonna flip the sign. Minus 15x. Now I'm gonna do the first one, and then you guys can see how I did it to find the second one. So the first thing I did, yeah, that's right, 15x, that's right. So the first thing I did is I'm focusing on canceling the 6x squared. What do I know? I need to multiply the highest term here, the highest degree here, the term that, that term that has the degree of this thing here. What do I need to multiply the 2x by to get 6x squared? 2x, of course, you multiply it by another 3x, you get 6x squared. Now, after I've done that, 6x squared, just like you would do regular long division, 2x times 3x is 6x squared. What you put here is you flip the sign, so 6x squared minus 6x squared. Same thing here, 3x times 5, 15x. What you put in here is minus 15x. So that's done for this one. Now let's scroll up for a little bit. So now what you're going to do here is add whatever the terms that you have, and then you continue the division. So what we're going to add here is what's going to be the remainder that we have is, after we add those, 6x minus 6x is gone, right? 6x squared minus 6x squared, that's gone. And that's the reason why you put the negative sign in it. 7x minus 15x, that's negative 8x minus 20. I'm not going to focus on sign here because I'm assuming if you're doing long division like this, you probably know the law of sign and stuff like that. And if you have any questions about it, let me know too. So 7 minus 6x squared is 7x minus 15x is 8x. Now, remember what I said, we're going to focus on canceling the highest term. What we have left here is 8x minus 20. I don't even worry about the 20 right now. I'm going to try to focus on the highest term. So what do I need to multiply 8x by to multiply 2x by to get negative 8x? So what do I need to multiply 2x by to get negative 8x? 2x, what do I need to multiply it by to get a negative 8x? Let me put plus here. What do I need to multiply the 2x by to get a negative 8x? And this goes over to 20. I need to multiply the 2x by what? Let me see if I can find an answer on YouTube. 3x. Oh, yeah, I see the answers now. Negative 8x. Negative 4. That's right. Maxim, Alana. Yeah, that's right. You're going to multiply by negative 4. I don't know why my comments are not coming here. Chat. Caption. Chat. My chat is not coming here. That's fine. So you're going to multiply to show on the screen message. I don't know why. Usually the chat shows automatically. I don't know why it's not showing. Okay, that's fine. Okay, so what you said is true. We're going to multiply by negative 4. I messed up your name. Our X and A. Okay, so we're going to multiply by negative 4. Yes, you multiply that by negative 4. And what are we focusing on is canceling the highest term. As long as we accomplish that, everything else should be fine. So negative 4 times 2, negative 4x times 2, negative 4 times 2x actually, as negative 8x. So when I'm bringing it down here, I just need to flip the sign. Negative 8x, positive 8x plus 8x. Negative 4 times the 5, negative 20. You're welcome, Katie. Negative 4 times the 5, negative 20. I'm going to bring it here, positive 20, plus 20. And then, guess what? Watch what happened. Negative 8x plus 8x, negative 20 plus 20. We're left with a big fat 0 remainder, and that's it. That's it. So that tells you if you multiply 2x plus 5 times 3x minus 4, you should get okay, I can do that, Michaela. I can do that. So you should get 2, because I have a lot of requests about domain. I'll do some of that. Notations. Okay, yeah, we're going to do that. Equation inequality, and then we do domain and range and stuff like that. So if you multiply what this div long division tells you, if I multiply 3x minus 4, actually, 3x minus 4, because that's, I put the plus here to say that we're going to add whatever is in there, but it's 3x minus 4. If I multiply 3x minus 4 times 2x plus 5, I should get this. Now, if I had a remainder of 1 or 15 or something, I would have to add it to that. So 2x plus, so what I'm saying is 2x plus 5 times 3x minus 4 2x, oh, 2x plus 5 times 3x minus 4 is equal to whatever this was. What is it? 6x squared plus 7x minus 20. And you try to do that, that would give you 6x squared plus 7x minus 20. So 6x squared plus 7x minus 20. So this is x squared plus 7x minus 20. And this is all it is to long division. And when it comes to conversions, physics, I'm confused how to set up the problem. I can go over conversions in terms of, if you're converting from, from meters to centimeters and stuff like that. There's only one way that I do them, and normally it works for. It doesn't really matter what class you take, and it works for it. I can show you how to set that up in a little bit. So now what I'm saying is, if I multiply the 2x plus 5 times the 3x minus 4, I should get 6x squared plus 7x minus 20. And that's all that there is to this one. And so bottom line is, when you're doing long division, the person who asked the question, when you're doing it, the one thing you want to focus in on is canceling the highest term, the term with the highest power. So that's what we focus on canceling. So first, what we did is we canceled 6x squared. We try to cancel that out. And then after that, we left with x. And then we're trying to cancel the x. After that, we're left with a number. The number just happened to cancel when we cancel the x. Otherwise, we would just have a remainder of a number. So, question? Let me see if you guys have any questions. I don't know why my chat is not coming up. 0. Thanks. No problem. I know I'm terrible at name. The X doesn't help at all. I don't know how I should pronounce it. Al-Exna. That's probably worse than Alana. All right, cool. Cool. Okay. Let's see. All right, no questions. We could do some simple integrals. We could do some simple ones for now. But if you have a specific question, it's probably better to send it to me. So let's do circle with W and open circle. Okay, so it sounds like you have a lot of problem with the open circle, closed circle stuff. So interval notations. Okay, let's do an example. Let's start with what we know. So let's try to see how to solve some equations. Then we're gonna go into solving inequality, and then we're gonna solve for interval notations. After that, we probably can go into domain and range. So let's do how to solve equations, things that will bring all of us on the same page and understand that, hey, this is how you solve equation. And then after that, we're going to be able to see that equation and inequality not really that much of a difference. It's just, instead of saying this x is equal to this, you say x is greater than this or less than this, and then we can write the notation. I'll show you easy way to remember the notation. So let's start with something simple. So let's say we have 2x minus 5 is equal to 3 and negative 3x plus, let's see what I could put here. That gives me 5 plus 10 maybe. All right, let's see how we can solve for this. Okay, so the first thing we want to do is, you guys know already, this is easy stuff. The first thing we want to do, and I'm going to use the same exact example to do inequality so you can understand that they're not that much different. You go all the way to the bottom, and then I think what you really having problem with is saying, okay, is it open circle, closed circle, and how do I write it in terms of interval notation? So First thing we want to do, and you can do these many ways, and I'll show you. I can probably show you 2 ways that you can do it. A faster way for me, and the way that you guys normally do it. Let's go with the way that you guys normally do it. So you add 3x to both sides, 3x, 3x, and then this is 5x minus 5, and this would give you 10, right? And you subtract 5 from, you add 5 to both sides, plus 5. Let me make a different color so you understand the steps. Plus 5, plus 5. I hope I didn't put equal here. I probably did. No, I didn't. So you add 5 to both sides. And then what that gives you is 5x. That 5 is gone. 5 plus 5. 5 plus 10 is 15. And you divide both sides by 5, of course. And you get x is equal to 3. Now, x is equal to 3. Let's see if that's the solution. 2 times 3 is 6. 6 minus 5 is 1. 3 times negative 3 is negative 9. Negative 9 plus 10 is 1. So 1 on this side, 1 on this side. That's good. Now, this is equality. So there's no questions on here. That you guys know how to do that. Now, if you're doing inequality, let's do the same example, the same exact example, so you can understand that they're not that much different. If you're doing inequality, let's go. And do you guys have questions about solving equations? And that should be me. What's going on? So you guys shouldn't have any questions. I'm not shouldn't have. You don't have any questions about this, do you? About the equality part. Okay, let's do the inequality stuff. So I don't know why this is not coming up though. Okay, let's do the inequality. So what we're gonna do is the same thing that we just did earlier, but in terms of inequality. So let's do 2x minus 5, negative 3x plus 10. And the person who asked about the question about inequality and writing them in terms the solutions and interval notations, this is going to be for you. So 2x minus 5, is that what we had? I hope. It doesn't really matter. It's equal to negative 3x plus 10. And I'll change color here for a second so you can understand. So what's the first step that we're going to do? Let's do less than or equal to. And that's the only difference between what I just did and this. Is less than or equal to. That's the sign. That's just different. The first thing that we're going to do is we're going to add 3x to both sides. The same thing. 3x here. 3x here plus 3x. So what does that give you? Is 5x minus 5 less than or equal to, that 3x is gone, 10, right? So we're going to add 5 to both sides, plus 5, plus 5. And what does that give you? That 5 is gone. 5x less than or equal to 15. Now, we divide both sides by 5. One class. We divide both sides by 5. What do we do? So we divide both sides by 5. Okay, we divide both sides by 5. We divide this guy by 5. We also divide this guy by 5. X is less than or equal to 15 divided by 5 is 3. Is that what we found earlier? Yes, 3. Okay. Now, how do you write that in interval notations? So how do we write that in interval notation? Like the easiest way to look at this is going on a number line. So let's say we have a number line right here. So this is 0, 1, 2, 3, 4, 5. And then when you go all the way out that way, you know you're going to infinity, right? To infinity here. And then -1 here, -2, -3, and all the way out this way is -infinity. Okay, so what the point that they give us is right on 3. So on 3, let's say we don't know where it's at, so let's say it's on 3 right here. Now, this point is on 3. What do they say? They want all the values of x that are less than 3 or equal to 3. Now, let's start with less than 3. Less than 3, that means 2, 0. You can literally say the numbers that are less than 3. -5, -10. So this guy is part of it. This is part of it. This is part of it. This is part of it. -1, all the way out to -infinity. So that tells you that, and if I try to color this in red, that tells you that the solution includes everything that goes this way, right? And I think I mentioned this before. When you write in the solution that way, now let's take care of, before I do that, let's take care of the, no, actually, let's do this first. So when you write in the solution in interval notation, all you have to do is following what you saw on the line. So I don't even have to worry about the 3 anymore. So what do I see on the line? On here, all the way to the left, I have a -infinity. And all the way to the right, I have a 3. After you get good at those, you're going to know how to do them like really, really fast. So I know at infinity, I have this. Now at 3, what do I get? Do I have a bracket? Do I have a parenthesis? This is how you think about it. And bracket means included, and put it in there. That's part of it. This means do not include it. So in here, what it said is, hey, this is less than all and also equal to 3. So that means it's also what and the other way that they call that is a closed circle. So it's also a closed circle, right? So do we put a bracket? Do we put a parenthesis? What do you guys say? Bracket, parenthesis? System of equations ever, even though it's probably easy. I think we can probably go over some here today. I'll show you a little bit. Okay. So what are we going to put it here? Is it a bracket or a parenthesis? I don't know why my chat is not coming up today. I'm not sure why. Parenthesis or bracket? What would you say? What would you guys suggest? What would you say? Let me see why my chat is not coming up. Test. So parenthesis or bracket? Let me see what you guys saying on YouTube. No change, the same name. So would you say this is a parenthesis or a bracket? Okay, so Lana said bracket. Yeah, so that's what the answer is. So you said include the 3 in the answer. That's basically what you say. Hey, I want all the answers including the 3. And then let me go step by step over what I did. So after I found the solution, parenthesis, Michaela, what do you say parenthesis? So after I found the solution, what I did is I go on the number line. I said, okay, on the number line, give me 3, because that's the solution, basically. And then they said, okay, give me all the values that are less than 3. Everything that's less than 3, I put it to the left of 3. You can actually start saying them. 0 is less than 3, -5 is less than 3, -1,000,000 is less than 3. You just put all of them. All those are going to be part of the solution. After I did that, I said, okay, the way my solution is going to be set up is all the way to the left, I have infinity, and you can see it because this is what your solution is. Everything else don't matter at this point. Everything else that's to the right, they don't. I can literally just erase them if I want to. My solution is negative infinity all the way to the left, and that corresponds to here, and then 3 all the way to the right, that corresponds to here. Now, the only thing I need to do, at negative infinity, you always have a parenthesis. It's bracket. Okay, yes, it's infinity. My bad. Good. Yeah, you put the bracket because it's including that value. So what I said is at negative infinity, I have a what do I have at negative infinity is a parenthesis. Now at the 3, do I put a bracket or a parenthesis? So it's a bracket if it's less than or equal to or greater than or equal to. So that means you put the bracket here. You put the bracket. Less than or equal to, greater than or equal to, you're going to always put a bracket. Now, if you have strictly less than or strictly greater than, you're going to put a parenthesis. And it's only 2 options. A bracket, less than or equal to. The parenthesis, strictly less than or strictly greater than. That means it cannot take that value. So if you can remember it this way too, bracket, you can take this value. Not included bracket, you cannot. I mean, the parenthesis, you cannot take this value, and that's all there is to it. There's not much to it. Now, there is another question that gives people a lot of trouble. So let's say I have the same. Let's say I have 3x negative 3x plus 4 is, and I'm not really focusing on is less than or equal to strictly less than. Let's do strictly less than, and I'm gonna see how you guys are gonna do this. Strictly less than, let's make this 7 maybe, -2 maybe. Okay, so now let's do this. So let's say you're solving for this inequality. The first thing that you want to do is saying that algebra 2, please. I mean, there's a lot of stuff in algebra 2. What do you want to see specifically in algebra 2? So let's say that you're solving this. The first thing that you want to do is, kind of like you do in an equation. You take 4 from both sides. You take away 4 from both sides. -4, -4. And then you have negative 3x here. That 4 is gone. And then -3 plus -2 is -4 plus -2 is -6. Or -4 minus 2 is -6. So now this is where a lot of kids get confused. When you get to this, if you have this, so let's say, let me the first thing I want to do is, okay, so here, I don't want to do this in 2-step. I want to do it in 1 step. I don't want to do this in 1 step. I want to do it in 2 step. If you were solving inequality, if this was an inequality, what you would do is just divide both sides by -3, and you would be fine. Now, because this is an inequality, one thing you need to do is make sure that you get rid of that negative sign that's in front of the x. And that x cannot have a negative sign in front of it because you're solving for x, not negative x. The first thing that you need to do is, and you can do those 2 steps, you can do whichever one you prefer, but to make it more sense to you, the first thing that you need to do, if you ever have the x that has a negative sign in front of it, you got to multiply both sides of the inequality by -1. And -3 here, multiply by a -1. And then on the right side, I have a -6 multiplied by a -1. Now, here's what happened. And I'll show you an example of that. That sign gets flipped around. It gets flipped this way. And the easiest way, I don't know if there's something that you can prove. I'll show you the easiest way to understand this. What is 2 is greater than 0, right? But if I multiply both of these guys by -1, what happened? 0 multiplied by -1, what happened? Do I have this sign? What kind of sign do I have here? What's the sign that goes here in the middle? So 2 is greater than 0. -1 times 2 is -2. 0 times -1 is 0. Which one is greater? 0 or -2? 0 is actually greater. So you see how we go from this sign, 2 is greater than 0, and then you have -2 is less than 0 when you multiply both sides by -1. And this is exactly what happened. Any numbers that you take, doesn't really matter. You take 1,000,000, -5,000. If you say 1,000,000 is greater than -5,000, when you multiply both sides by -1, you got to flip the sign. So this is what's going to happen here. Multiply both sides by -1. And this is going to be flipped. So -3 times -1, that's 3x. -3x times -1, that's 3x. Not -3x, that's a 3x. And then you have -6 times the -1, that is 6. Now, what you did with the sign is, yes, this needs to be flipped. So greater than. Now, after you get rid of the negative sign that was in front of the x, notice if this was the only thing that had a negative sign in front of it, we wouldn't have to do none of this. The only time you have to multiply both sides of the equation by a -1 is when you have a negative in front of the x, the term that has x in it. So what you would do is, just like you would do in equality, you would divide both sides by 3. Divide by 3, divided by 3, and you get x is greater than 2. Now, how do we write the solution? Who can tell me, before I write the solution, who can tell me in interval notation, are we going to have a parenthesis or a bracket? Let me see. I think Michaela, I think you're the one who asked the question about this. So let's do the number line. Number line 0, 1, 2, 3, 4, and I'll stop here all the way out to infinity. -1, -2, all the way out to -infinity. Now, what do we say that the solution is? X is greater than 2. And let me write it here for you. X is greater than 2. Strictly greater than 2. Michaela, if you could write the solution for me in interval notation, that would be great. I think you are the one who asked the question. So, how do we write the solution? X is greater than 2. Let me think of some values that are greater than 2. 3 is greater than 2. 4 is greater than 2. So all of those are going to be part of the solution. 3, 4, 500, 1,000, 1,000,000, all the way out to infinity. But what do I do in this 2 right here? Now, because it's net, it doesn't include 2. That means it's a open circle. Open circle. Now, how do I write the solution? Before I do that, actually, before I do the open circle thing. So this is the solution. Everything else, I don't even have to worry about them. So the solution is going to start from 2 and all the way out to infinity. I can go in my stuff. I can say 2 infinity, and then I put a parenthesis at infinity because that's always infinity. Now, what we do at 2? Is it a bracket or a parenthesis? Who can tell me what we're gonna put at 2? YouTube. I'm guessing no. I think that was a comment from earlier. So what do we get at 2? Michaela? Parenthesis, Lana, parenthesis. Okay, you guys starting to understand this. So parenthesis at 2 here. Yeah, that's right. So the solution goes from 2 all the way out to infinity. So is this a closed circle or open circle? In this case, is this a open or closed circle, or is it this? Or is it a closed circle? Open circle means do not include, strictly less than or strictly greater than. Closed circle means include, less than or equal to or greater than or equal to. So what we have here, is it a closed circle or an open circle? Let's see what you guys have. Open, that's right. Lana, that's right. Okay. Never mind, open. All right, good. I was gonna ask you why you say closed. Yeah, it's an open circle because it doesn't include it. Cool. All right. So let's try to do something different. Let me see if I can see what we're gonna do. Let's try to do something else. I think you guys asked about something else that I said I was gonna do. Okay, so domain and range, right? And then system of equations. So what do you guys want to see? Any tips on calculus? I don't know if I have any tape for you, any specific tapes. You know, it's like a whole course. Okay, domain and range. You guys want to see that? It's like a whole course. So I would say, you know, try. I mean, I always say this here, and you guys probably know this is true. Find the best way that you learn. You know, for me, it's video. I can watch sit down and watch a bunch of videos. For you, it might be pick up a book. Find that best way that you learn and do it. But and learn that way. The most important part I would say about taking any class, it doesn't have to be calculus. Just make sure you practice. That's all it is. Because you won't be able to, you know, it will make sense in class. What I'm doing now probably makes sense to you, like open circle, closed circle. That makes sense. Yeah, I understand. But when you go and do it by yourself, it's something completely different. Until you do enough of them by yourself, you probably won't be able to understand it to a point where if you have to do it in 15 minutes, you will be able to do it. So I would say practice, a lot of practice. Hey, what's up? 7EMZA011. 0111. What's going on Instagram? What's up, man? So, so two things. Find the best way to learn, and it's the same thing. Find the best way you learn the material that way, and then practice. So that's what I would say. Okay, Cindy want to see domain and range. All right, let's see. Let's do some stuff. I think I said I would do those. Domain and range. Domain and range. Okay, cool. So let's talk about domain. Domains, the easiest way to think about them is, you know, what are the possible inputs? So in a function, there are inputs, there are outputs. So let's say you have the function this way. So this is the function. There's stuff that you put in it. Now, and I'll show you. We're going to do some simple examples today. So there's stuff that you can put inside of the function. So I can put this square here, this triangle. It doesn't really matter what they are. I can put them. So think about your controller. You know, if you play video games or you know how to turn on the TV. When you press 2, that 2 shows up on the screen. So the 2, you know, the input 2 shows the output on the screen. That's 2. If I push, I don't play a whole lot of video games, but if I push A on a Nintendo Switch, if I'm playing Mario, I don't know, what does it do? It jumps. So the input is pushing A. The output is Mario or Luigi jumps. So this is what you think about the input or output. So each function has input, a set of input, a set of output. Now, when you're talking about domains, so certain functions have certain input that are not possible for that you cannot put in that function. So the example that I always give is if you have an oven, you can't put, you know, you can just throw you know, some papers on it you can't just throw your notebook under the oven. You know, something will happen. It will cause a fire. That input is probably considered like an input that gives you an output that you wouldn't want. But if you want cooked chicken, you just put raw chicken, and the output is cooked chicken. So the sets of outputs are like, you know, these are the outputs. So I put the input here, I get an output. I put this input here, I also get an output. It could be a different output. That input, that same input can go to this output. That same input also can get this output. Now, in a function, the reason why it makes it a function, each one of the inputs are only associated to at most one output. You can't have this input here. So let's say if it's f of 2, it's only gonna give you 4. It can't give you 4 and 7. That doesn't make it a function. That doesn't make it past the vertical line test. And what exactly the vertical line test is saying that, okay, if I draw a line on 2, how many outputs I'm getting. So if I have something like this, if I do a vertical line test, if I have a vertical line test here, if it touches here, it touches here, that means it's not a function. But if I have something like that, I do a vertical line test, that's not vertical. A vertical line test is only touching in one point. And that's what exactly happens in a function. You need to touch it in one point. Now, when you talk about domain, we say the sets of input. And I'll tell you that are possible that you can put inside of the function. Now, possible in the case that they're talking about is in terms of R. It's saying that you want, if you put a value in, like if you put a number, or it could be a rational number, irrational numbers that are from R, the output needs to be something that's in R. So if it's not something that's in R, we say that it's not part of the domain. So if I put the input, so let's say if I have the function 1 over x, and I feel like I'm jumping ahead, if I have the function 1 over x and I put the input of 0 here, the output is 1 over 0. The output is 1 over 0. That is undefined. In R, that doesn't exist. So what we say is that specific 0 is not part of the domain. Now, let me show you an easy way to think about domain, and you probably get it. So let's say I have a function. So let's say now you guys probably know this is probably, you don't have to write f of x when you write in a function. You can say 3 goes to 7, and then let's say this is the function f. 4 goes to 8. 5 goes to 9, and 6 goes to 7. That's a function. That's actually a function, because 3 and 6, they can both go to 7. If you think about the function f of x is equal to x squared, 2 and -2, they both go to the same output. They both go to 4. So now, when I'm thinking about domain of the function is the sets of all input. Now, because this is obvious, what is the domain of this function? If you guys can tell me, what is this domain of this function? And now remember what I said: the domain, set of input; range, set of output. So domain, the x values, the set of inputs; the range, the y values, the set of output. So now, if you're looking at this function, what would you say the domain here is? What would you say the domain here is? And I feel like I'm giving you the answer too. What's the domain of this function that I just wrote? So if I have this function here, f, that takes each one of those values and give them this output. So when I pass 3 to f, it gives the output of 7. If 4 goes inside of f function, it gets an output of 8. 5 goes inside of the f function, it gets an output of 9. 6 goes in it gets an output of 7. Now, what would you say the domain of this function is? Let me see. I don't know why my chat is not coming. That makes no sense at all. What is the domain of this function? Okay, domain 3, 4, 5, and 6. That's right. Now, what's the range of this function? Good job, George. Yes. What's the range of this function? What's the range? Yes. What's the range of the function? So what's the range of the function? And then I'm giving you the answers. What's the range of this function? And if we find in the range of the function here, what is the range? And 7, 8, and 9. That's why. That's right, George. Yes, 7, 8, and 9. So the range is the possible output, just like we were describing. We said input is whatever you put in, and range is output. Instagram, we are about to cut it off. I think I'm limited to about an hour on here. So, but I'll bring it back again. So the range is set of output. So now we get this function here in front of us. We say, hey, I know what the domain is because I can see it here. I also know what the range is because I can also see it here. Now, what the problem is when you have a function that's not defined that way, where you can see all the possible inputs. So I see a possible input here, a possible input here, a possible input here, and possible input here. Now, I don't see the possible out. I can also see the possible output. Those are the possible outputs. Now, if I have a function, let's say if I start saying that f of x is equal to something, I say f of x is equal to x squared. Now, we don't know all the possible inputs because you can put many different values in it. In this case, the way I define this function right here, I say the only values that this function takes is 3, 4, 5, and 6. And that's what you just told me. You say, hey, this function only takes 3, 4, 5, and 6. And that's the domain. It only spits out 7, 8, 9. That's the range. Now, if I have f of x is equal to x squared, that's a different problem because I don't know all the possible inputs. I know them. I mean, I can describe them using a notation, a symbol, but I can't pinpoint and say, it would take me forever to say all the possible values that I can put inside of the function. Now, this is why when you write in a domain, usually you write the set of all numbers except for these guys. And that's what I'm going to show you here. So let's say you have f of x, and we're going to go into stuff that have, that you probably see in real life. All right, so let me try to go back on. Oh, Jesus Christ. I don't think I saved this. That's terrible. All right, that's fine. So let's try to go back. Welcome back again on Instagram. So we're doing domain and range of a function. So when we have a function that's defined in a way where we don't know all the possible values. So what we do is we write it in a notation using symbols, using intervals and stuff like that. So let's say we have f of x is equal to x squared. Now the possible values for this is a lot. 1, 0, 5, 7, 600, 700. There's no, in terms of real numbers, there's no values that I can put in here that doesn't have an output. All the values here have an output. All the x values here have an output. All the input have an output. Let me know. Hey, you guys have any questions? Is this making sense to you? Is this making sense to you guys on YouTube, Facebook? I'm not sure. I don't know. I might have to go back on Facebook and see. Does this make sense to you guys? So all the possible values, what we're saying is, hey, everything that I put in here, I'm gonna get an output for it. Whereas if I define my function this way, like I said earlier, f of x is equal to 1 over x. There are certain values that I cannot put in here. And there are certain values that specifically cannot put in here. So if I define a function this way, if I put 0 here as input, what do I get as 1 over 0? That is undefined. And that's not a value in R. That's not a value in R. So 1 over 0 doesn't exist in R. So what we say is 0 is not part of the domain. So the way we write the domain is the set of all x such that x is different from 0. You could write it this way, or you could write it as negative infinity, 0, and then this is where you use your parenthesis because it doesn't include 0. Union 0 infinity. I don't know if they have you guys write it this way. That's another way to write it. Or you could say R instead of all values in R except for 0. So such that X is different from 0. So the set of all X such that X is different from 0. So you could say this here. That's one problem that we have. So usually what gives you a different domain is a domain that's not R, that doesn't take all the real numbers. If you have a fraction, the terms under the denominator cannot be 0. If you have a square root, the terms underneath the square root cannot be negative. So they have to be greater than 0. So let me give you another example. So let's say I have 4x minus 2. F of x is equal to 4x minus square root of 4x minus 2. So what's the domain of this function? What would the domain of this function be? Let me see. Let me see the chat. What's the domain of this function, guys? YouTube. George, Lana. Everybody else on YouTube. What's the domain of this function? I'll wait for you guys. So it's the set of all values such that something happens. So it's a set. So like I said, when you're dealing with square root, you need the term underneath the radical to be greater than 0. So we need the terms underneath the radical to be greater than 0. So what I'm going to focus on is saying, how can I make x minus 4 plus 2 is greater than 0? So I add 2 to both sides. And that tells you about solving inequality is kind of important. And then this is what? 4x is greater than 2. And x is greater than, actually greater than or equal to, because you can take 0. Square root of 0 exists. X is greater than or equal to 1/2. So you divide both sides by 4. X is greater than or equal to 1/2. And what that tells you is any value of x that I put here that's greater than or equal to 1/2 is part of the solution. So 1/2 is part of the solution. If I put 1/2 here, 1/2 times 4 is 2. 2 minus 2 is 0. Square root of 0, that does exist. 5 is part of the solution. 2 is part of the solution. 15 is part of the solution. Those are all the terms that's going to make this exist. Now, if I'm looking at the range normally the easiest way to look at to do them is, looking at the y values. But the other thing that you can do here in this case, saying, okay, I have f of x is equal to square root of 4x minus 2. What are all the possible outputs? So if I put something underneath the square root, that means I'm going to get positive values. So what are all the possible outputs? All the possible outputs going to be things that are 0 or greater. So if I put here, whatever the output of, so if I have f of x is equal to the square root of something here. Now, I already specify in the domain that everything that I'm going to include in this needs to make the function greater than or equal to 0. As what I'm saying in the domain is, if I put in an input in here, it needs to make the function greater than or equal to 0. So if I put the input of 5 in here, that's possible. If I try to put the input of 0 here, or -5, and -5 times 4 is -20, -22, square root of -22, you can't do that. So the range is all the possible values that are greater than, it's going to be values that are greater than 0, because whatever the square root function going to spit out is going to spit out stuff that are greater than 0. So Yes, no, understand? Let me see if you guys understand. If not, I can explain this a little bit different. So you that way you make sure you get it. I'll make sure you get it. Let's see if you understand. Yes, from one half to infinity. So yeah, that's right. Yes, that was good. Yeah, and yes, that's what from one half to infinity. So, and that's it. That's all we. That's the way that you understand those. So we talk about the most common cases. We talk about whenever you have a denominator, the terms underneath the you know terms. So if you have some function, let's say you have f of x is equal to some function g of x divided by some function h of x, what you want to do is making sure that this function is greater than 0. If it's a radical, you want to make sure that it's no, actually different than 0. Different than 0. If it's a radical, you want to make sure that it's greater than or equal to 0. And those are like most of the cases that you're gonna find, and it's gonna involve some combination of those. And there's of course you have the log function and other functions that you can put only specific values in them, but those are going to be specific to that function. And they can combine them and give you stuff that are different. But what I really wanted to do in this case is showing you, explain to you what the domain and range is, and also give you kind of like a example about stuff that can occur. So another thing that they like to do is saying that, hey, if let's say I have f of x is equal to 1 over square root of 5x plus 3. Now, here's the thing. That's a combination of two things that they give us. They give us, though, the denominator needs to be, because it's under the radical, it needs to be greater than or equal to 0. But also because it's also a denominator, it needs to be different from 0. So what you want to do is making sure that this 5x plus 3 not only greater than but it's going to be strictly greater than 0, actually, not greater than or equal to 0. So let me explain that in a little bit different. You got to understand that this case is a combination of two cases. It's kind of like you have the 1 over x, and it's kind of like how you have the square root of x. The square root of x, I want to make sure that it's greater than 0. It's greater than 0. Whatever is underneath the radical is greater than or equal to 0. But also because it's in the denominator. So after I make sure that this is greater than or equal to 0, and I look at it, I say, oh, it's in the denominator. That means it cannot be 0. That's why you want to make sure that this is greater than 0. Now, this is a combination of all of them. They can give you a bunch of examples like that. Any question? You gotta go on YouTube to see that. Let's see. Thay. I don't want to mess up your name. You gotta go on YouTube to see what we're talking about. Just Google the Jack Studio on YouTube, or you can go on this page and look at the YouTube channel. It's live on YouTube now. That's where you'll be able to see the screen. Everybody else is there. Okay. Any questions, guys? Anything else that you want to see? Yes, no, maybe. Anything else? Let me see if I should probably check the Facebook. Anything else that you guys want to see? Instagram, TikTok? Nope. Lana? Nope. Okay. All right. So, next time we'll come, we're probably going to talk about some other stuff that we didn't get to see here. Let's see. Page 21. I think somebody asked about a slope, and somebody asked about other things that we didn't get to see. Next time we'll make sure we look at those. So today we did that, the fractions with polynomials and dividing polynomials, that stuff we did. And we didn't talk about point slope form, and I think the sequences, I see a lot of questions about those. Next time we're going to talk about arithmetic sequence, geometric sequence, and we're also going to talk about, I'm not sure what this question was specifically, parallel and perpendicular line. Not sure what it was. Yeah. Can I borrow a pencil? Yeah, here you go, man. Here you go. Real, real dirty can. Here you go. You can just use this. Um, yeah. So that's it. That's it, guys. And I think this is it for tonight. I don't see any questions. Uh, Next time we're going to talk about the stuff that we didn't talk about. So what do you want to see next time? Let me know what you want to see next time. My hair is nappy. I appreciate it. What you want to see next time? Calculus. Okay, what specifically? What do you want to see specifically in calculus next time? But you gotta show up. So if you don't show up, you don't. We know you. We probably won't answer your question. Let's see. Let me see on YouTube and see what you guys want to see next time. No problem. I gotta figure out how to pronounce your name. Yeah, geometric and arithmetic sequence. Okay, we're gonna do that next time, George. Thank you for participating too. You answered a lot of questions this time. No problem. All right, so next time we'll talk about the sequences for sure. Complex and imaginary roots. Okay, so I'm assuming that you solving equations or that requires imaginary roots. Let me see. 1 addition. No, that wasn't. Yeah, 1 addition 24. Complex and imaginary roots. Are you solving equations that requires you to use imaginary roots? Complex and imaginary roots. It's only Devin. What's going on? Complex and imaginary roots. So, what else? Okay, yeah, okay. So something like x squared minus 5x plus 72 or something like that. That probably requires imaginary roots. I didn't check that. B squared minus 4ac. Yeah, something like that might require imaginary roots. So yeah, we talk about something similar to this. Anything else, guys? Derivative. Okay, you taking calculus? Okay, so we can do some derivatives. I think I saw somebody say integrals too. Somebody said they need help with integrals, derivatives. I'll be sure you probably don't. You probably one the person. You're probably one of the few people who talk about that. AP. I need help with AP Calc. AB. Yes. What do you need help with specifically? Derivatives. So x squared f prime is equal to 2x, stuff like that. F of x is equal to x squared, f prime of x is equal to 2x, stuff like that. Thank you. I appreciate your help too. Fnee Logan. Thank you. Same to you. You have a blessed life as well. Yeah. So that's all, guys. So I have complex roots, derivatives, and then we want to make sure I got to make sure I at least start with those sequences and series, all that kind of stuff. Well, we'll do a lot of them. We gotta do a lot of them next time. I don't see any more questions about SOHCAHTOA. Okay, if you go on SOHCAHTOA person, if you go on the last 4 live, I feel like we talk about this a lot, but I'll put that in there. I don't know if we're gonna exactly touch on it that time, but SOHCAHTOA. But we can we can touch on it. I'm trying to see if I answer some questions on Facebook. All right, so what we're doing now is what you want to talk about next time. Let's see. Thank you. I appreciate you. Grace, I appreciate you. I don't know what's going on with Facebook. Okay. So I don't see any other questions. Bye. Lana, bye. You have yourself a good night. And it is bye for you two guys. And I will see you all later. My battery is dying too. I will see you guys later. And it was nice hanging with all of you. And yeah, next time. Next time we'll come by and hang out again. And I appreciate you all for coming by, and we'll talk soon. Bye.